Attendees will see your face once we started. So no worries. We are starting. Olaf, do you hear me?
You're muted, so.
Sorry, yes, a bit early for me in the morning. Yes, I hear you well. Thanks.
Oh, okay.
And there's nobody in it.
Yeah.
Oh, yeah, we're supposed to start.
Right.
Yeah.
Triples in
Especially with those, like some programs they have.
Yeah.
I feel like normally Kai has 3 screens as well.
What?
They normally have like 3 screens as well.
Yeah.
States that this stuff is now mainstream because they have the biggest room. And it's sort of a weird claim right now.
Yeah.
Do you like a Netflix topic?
Is it all good?
Okay.
Okay. Incredible.
Maybe that's
Olaf, we are up. Maybe once we turn 4-3, we can start.
But I did want to ask you, so with the Year's band that you
Okay.
so is it like how
3, 2, 1.
the members. Yeah. They're like $250. And they've got, I don't know how many customers they have, but they're quite willing to give you
It's here.
Uh,
I know.
you don't have to pay an invoice.
And Olaf, when you're presenting, I'm going to control your slideshow. So I can sense your context, so I can move the slides for you. But if I didn't, please say just thoroughly, like next slide or something. Then I can move to the next slide.
Okay, so you're gonna advance the slides. All right, good.
So you don't have to share your screen or anything.
Okay, sounds good. Thank you.
You see the slides, right? In Zoom.
Right now, I don't. No,
Okay.
but I can also share them if you want.
It would be better if you didn't share them.
You can measure how interested you are.
okay, yeah. So, do you think it works?
I feel like it does respond to like doing mental. Yeah, there's all that.
Now I do. Perfect.
Hello, and
3, 2, 1.
hello, everyone.
Welcome to
our
our panel,
panel,
NeuroCHI. I am Yudai Tanaka from University of Chicago.
And I am Angela Vuich from MIT Media Lab. So, NeuroCHI is a portmanteau of neuroscience and computer-human interaction, or CHI. We're here to promote more discussion around interactive systems that apply to the brain and the nervous system for both input and output. We are witnessing the emergence of novel sensing and stimulation technologies that can create new applications in HCI, while at the same time, we see a surge of new kinds of AI-based decoding that can detect stories and images directly from fMRI signals and more. And also the commercialization and miniaturization of brain sensing input and output technologies in the form of headbands, wristbands, headphones, and more.
So this over the last decade was also a fruitful period for also the HCI community. So HCI researchers have proposed and developed all these translative work that applies and built on these exciting neurotechnologies for both input and output of the interactive systems. So we are really observing the emergence of this interesting subdomain in HCI, NeuroCHI, but it is currently faced with different types of challenges, from technical challenges including resolution of the reading and stimulation, the form factor of the devices, or even the user interfaces of these technologies, to more meta-level social acceptability or even ethics. So today, we are going to discuss these challenges and the opportunity with these amazing panelists here. So we are going to jump onto the panelist introduction. We are going to start with the moderator, which is Angela, and then myself, and then the panelists, okay?
Right. So we're going to move over here for the remainder. Let me just make sure my microphone is all good. So, a little bit about my research background. I am interested in emotion brain-computer interfacing, but historically it's required significant data collection, complex modeling, and also bulky hardware. And really, my research looks at how these kinds of interfaces can be made with as few as 2 electrodes, minimal training, and wearable devices. And what I found is that instead of over-engineering our current approach, that we should be rethinking our data sources, models, and methods. An example of this is that we can think of new sources of brain activity. We have a second brain in the body called the gut brain, which has a few hundred million neurons embedded in the gastrointestinal tract. And this influences emotion, motivation, memory, and more. With this,
Okay.
no, thank you. With this, I've created a wearable gut-brain computer interfacing using accessible hardware and resources that with as few as 1 electrode can pick up on frequency and power-based differences in stomach activity that are associated with emotion. In addition, we can think of new models of brain activity. Approach and withdrawal motivation is not very well studied in HCI, though people like Gabor Arani and Mark Cavazza have presented work in this area at WIST. And then last year, I had a follow-up interface which showed that approach motivation can be activated by joyful thinking. And we use this to create a brain-computer interface called joie, French word for joy, where users could modulate their prefrontal alpha asymmetries to control a character in a video game. And we even showed that it could be implemented with dry hydrogel electrodes that you could imagine one day being implemented into things like headbands, XR, and more.
All right, that's great work, Angela. So I'm Yudai Tanaka, and I'm also a moderator here. So I'm working on the output side of nervous intervention, and specifically about haptics, such as sense of touch. So unlike wearable sensing, the actuation side of these devices are much larger and more cumbersome. So as you can see today, if you want to output something you can feel in your skin, you have to wear something like these haptic globes. So I'm asking this question of, how can we miniaturize and allow the user to feel these senses without wearing these devices on their body? So instead of attaching devices to the user's skin or covering up the user's body, I intercept the user's nervous system to create the sensations remotely from different locations. For instance, in the last year's CHI, I presented a way to create touch sensation to the user's finger parts or the palm without attaching anything to the user's hand. The way we did that is instead of attaching devices to the hand, we stimulated the back of the user's hand with tiny electrical pulses that can strategically create the perception of touch sensations in the user's palm and finger parts. But when we think about these approaches, eventually the nerves are all converged at one point, the source, which is the brain. So this year's CHI, I'm generalizing my concept to a device that can present the sensations by stimulating the user's brain. So this is a magnetic coil that can safely and non-invasively stimulate the user's brain called transcranial magnetic stimulation. So by moving this stimulator across the brain cortex, we can create sensations to user's face, hands and arm, and the feet and legs, all by stimulating the corresponding cortex part of the user's brain. All right, these are our moderators' work, and now we are moving on to the amazing panelist introduction, starting with Professor Patty Mice.
Thank you, Uday and Angela. So I'm Patty, and I want to start by saying what or how I would define NeuroCHI, basically as direct brain and nervous system input and output. So not just brain, but also peripheral nervous system. So why is NeuroCHI the destiny of human-computer interaction? I really believe this, and I'm not the only one. Some of you may have read the philosopher who I think is really the most relevant philosopher alive today when it comes to...
Next slide.
Oh, oops. When it comes to human-computer interaction, and that's Andy Clark from the University of Sussex. He argues that people are unique among all species by being natural-born cyborgs. He argues that we have this long history of basically inventing tools that extend our intelligence, extend our capabilities, and especially when these tools are very powerful and very useful, we tend to move them closer and closer to our bodies. So we've seen computers moving from mainframes to desktops, to laptops, to smartphones, to wearables. And the next natural progression is integration of people and machines, because machines extend our capabilities and allow us to do things that we could not do without the machines. Now, I also personally believe that this is a very interesting research area to look at, or research approach, because all of us here at CHI are trying to research and invent interfaces that are seamless and easy to use, etc. Now, what is more easy and seamless to use than an interface that gets out of the way, that disappears, because the system reads from your nervous system, from your brain, what your intentions, what your desires are, what your state is, your focus, etc. And it can directly also influence your brain and nervous system so that you can accomplish the goals that you want to achieve. So today's interfaces are almost all sort of use conscious pathways to interact with the user. And what that means is that we have to, basically the interface always gets in the way of whatever it is that we're trying to do, because we have to think about how we input something and give instructions to the system, how we interpret its outputs. And I think that eventually we will just have systems that, again, don't require input, conscious input and output, because the systems will read our mental state, our intentions directly from the brain and nervous system, and they will also stimulate our brain and nervous system to support us using, once again, non-conscious pathways that we may not even be aware of that they are happening. So some examples from my work in that area. On the side of reading, directly reading from the brain and nervous system, we've done work like Natalia Kosmina's work on reading fatigue and workload and attention from wearable EEG and EOG. Angela already showed her work reading emotional state of the user, like approach and withdrawal from EEG. My student Arnav Kapoor has been working on silent speech, so that people can input speech without actually having to speak. Just sort of consciously thinking about the words that they want to say. We've also done a lot of work on direct stimulation of the brain and nervous system to try to help a person with whatever intention they have. We've done work on electrical stimulation of the vestibular system to enhance the sense of presence. We've done temperature stimulation on the back, causing people to have frisson or chills, and that has certain implications for the emotional state and cognitive state of a user. We've done work by Walt, who's here, Walt Danwy, on creating synthetic visual sensations by directly stimulating the brain. Just this morning, we presented a paper here on improving a person's attention, not by telling them, pay attention, but by stimulating their nervous system with with rhythmic stimulations that naturally improve their ability to sustain their attention. We've done work on improving memory with targeted memory reactivation, Judith Amoris's work from last year's CHI, and so on. So I would like to argue that this type of technology, NeuroCHI, is incredibly exciting, incredibly promising, that we have this potential for effortless input and output using these new pathways. But at the same time, and there's numerous applications like in our work, better sleep, memory support, emotion regulation, optimizing performance and cognitive state for a task, enhancing the senses and more. But with all this great power, naturally the two always go hand in hand, comes a very big challenge. If we read directly from the brain, from the nervous system, if we write directly to the brain and the nervous system and the body, how do we guarantee that the person remains aware of how they are being manipulated or how they are being read? And how do we make sure that they remain in control ultimately? So that is, for me, the big challenge that this field has ahead of us, and that's why it's really something that should be tackled by HCI. This is what HCI people are good at. And so I would argue we need a whole new sort of special interest group here at CHI that looks specifically at these types of challenges, not just the technology, making it small, etc., real-time, wearable, and so on, but also the ethics of how do we do all of this without a person ultimately being manipulated by the machine, being a slave to the machine, or whatever forces that are behind the machine, and their data being compromised potentially, and so on. Thank you.
Thank you so much.
All right.
Next, we are delighted to introduce our next panelist, Professor Olaf Branke from EPFL. Olaf, you can start your presentation.
Okay, thanks, Udai and the organizers for the presentation. I'm going to continue along the lines that Patty has mentioned. I also think it's really fundamental that CHI follows this neuropath very strongly. I'm going to focus on some particular examples, going from body perception first, a simple problem from body perception. What's the relevance of this type of body perception for self-consciousness, and then human augmentation. So we all feel one left hand, we all have one left hand, but from the brain's point of view, that's not so trivial, because even our left hand, we can look at the hand, we can, with closed eyes, we can feel that hand, we can feel a touch, and we can snip it. So there's 4 representations, because these 4 left hand representations are in 4 different parts of my brain. So how is the brain fusing that in order to create our lifelong experience of just having one left hand? Next slide, please. And if you can click one more time, you will see on the left side a video, a rubber hand illusion, where exactly this can be disrupted, where the feeling of having one hand is disrupted in a sense that it is shifted to that pink visual rubber hand or fake hand that you see that the blue person, the experimental subject, is looking at. I think the video should play maybe one more time. And what is happening, the time is short to present you this, but what is happening is that there's one hidden hand of the subject, and then there is another hand in clear sight, a visual hand. And since vision is dominant in terms of spatial location over feel or touch sensations, this hand is or comes to be perceived. This thing, although it doesn't look at all like a visual hand, like this person's hand, comes to be felt as my hand, is owned, if you want, is embodied. And in this rubber hand illusion, of course, much is done in, there's over 2,000 citations and papers of this work, but it allows to show that it's very active, an active brain process to feel a left hand or right hand, or what this means also body. Next slide, please. And I have a few applications of this. So what can we do? How can we engineer artificial hands that also feel ownership and that feel like my hand? This is very important for prosthetics. On the left side, you see one clinical example where chronic pain can be overcome by embodying a virtual hand that our patients have seen on virtual reality. And you click one more time, more closely to NeuroCHI, you can directly write signals, electrical signals into peripheral nerves. And then in collaboration, we have shown that even amputees who don't have a hand can embody a phantom limb and a prosthetic device that is positioned, of course, at the position of the phantom limbs. And so you can also induce and employ this neuroscience and psychology knowledge in order to embody future devices that we will have. And this is not just of relevance for amputees and artificial limbs in order to heal or to treat, but in the middle I show you an example from people where we studied individuals with 6 fingers on the left hand, 6 fingers on the right hand, and we were interested, how is the brain representing the supernumerary finger? Much to our surprise, the index finger, the extra index finger, if you want, which was positioned between the thumb and the normal index finger, was actually represented just as any of the other fingers in 5-fingered individuals between the index and the thumb. So the brain is totally integrating those artificial devices, artificial fingers, and the argument would be that strong embodiment, feeling that these are really our fingers for future artificial devices and artificial limbs, will be a powerful tool for human augmentation. Next slide, please. I won't have time to go into detail, but I think in particular one system is powerful. It is directly linked to the hand system I presented to you, but it's a similar system that can be studied in very similar ways, like in the rubber hand illusion, but now what we have termed full body illusion. So here the stroking between a hidden body and a seen body is between an avatar that you see wearing a head-mounted display and touch cues that are applied on the back. So instead of the hand, the back or the torso is stimulated. We don't do much with our torso in terms of touch and proprioception, but I think it's a beautiful, huge terrain for human-computer interfaces. And you can induce, next slide please, a range of sensations. You can embody avatars in these surrogate bodies, and what we are interested in next to what the relevance is for self-identity and self-consciousness is that we're currently exploring how these self-conscious or embodied avatars, surrogate bodies, can be helpful in spatial navigation, also in episodic memory. If you want, it's a kind of spatial navigation in our lifetime. So again, no time to go into this, but this is really merging human-computer interaction, brain-computer interfaces, and very particular human important cognitive functions. Next slide. I think very briefly that once you talk about this torso system, there's a whole other range of systems like aviation, robotics, drones, motion platforms that I don't have time to go into, the sensation of flying, for example. But on my last slide, or my second to last slide, I wanted to go more deeply. Yuda, if you can advance the slide one more time, and also click on the video. So going directly to brain-computer interfaces, here a collaboration with West Virginia University, Ali Rezai, where a brain-computer interface here is implanted, so this allows to
analyzed within microseconds and translated into signals that allow an external stimulus to be able to move his hands. He has gone from small movement of his fingers to much more sophisticated and progressive movements.
For me, it's not about walking. What if I can begin use my hands and be more independent? That'll change my life forever.
Okay, so So this was a brain-computer interface in a tetraplegic individual, Ian, that you've seen on the video, and he regained control, volitional control. And this is what mostly is done in brain-computer interfaces. What we were interested in, how can we change and manipulate and decode his sense of agency, his sense of control, and we were able to actually manipulate without him knowing this during experiment. Of course, he was fully aware of this. We could also investigate something with the Libet paradigm called free will, or the issue of volition. And so these aspects of self-processing, very much like the rubber hand illusion and the full body illusion, can also be targeted by human-computer interfaces, but also by brain-computer interfaces. On my last slide, you asked me, like the other panelists, to end with a few comments. So the first one is really that this is just the beginning, and I think looking at this particular system, not at all body signals, but particularly at signals that integrate vision, touch, proprioception, movement, and sound for the hand or for the full body torso, will be a very powerful brain signal to control, first of all, embodiment of artificial limbs, supernumerary limbs, and also for human augmentation. I gave some directions like identity, self-identity, and memory. Obviously, a key topic to discuss is also, this is strongly needed for many neuropsychiatric diseases for which we simply have no cure today. Think about Alzheimer's disease, but many other conditions, of course. And then the last point, again, Patty mentioned it already, I think ethics is going to be very important. There's unprecedented, I think, consequences that may occur. So strong ethics, in my opinion, experimental ethics, so really targeting potential ethical concerns directly in these interfaces will have to be developed strongly and in parallel. Thank you very much.
And next we will hear from Rob Jacob.
Thank you. Oh, which one is it?
The green.
The big green button. That was easy. Okay, hi, I'm Rob Jacob. So here's my argument for BCI going mainstream. Ask anyone in the hall outside or anyone on Waikiki Beach, what do you think user interfaces are going to be like 50 years from now or 100 years from now? And I hope the answer isn't going to be, well, they're going to make the mouse, it's going to have more buttons and it'll be more, like, come on. The goal of HCI is to communicate between people and computers, and all these gadgets, I think, are eventually going to go away. That ultimately, it's got to be between the brain and the computer. Maybe not real soon. Don't invest your money based on this, but I think this is, as a scientist, I think this is the place to look. So me and the other panelists, but not most of the BCI world, are in this very small corner of the world. Most work on brain-computer interfaces has been targeted at disabled people, like really disabled, can't move anything. And you've probably seen these stories. Oh, thank you. No, I don't want to, okay, it's good. And you've seen these stories. It's a life-changing benefit. You implant the electrodes and this person can finally communicate again. It's unbelievable. Life-changing benefit to, fortunately, a tiny number of people. There's not that many people with this horrible condition. So we're trying to do the opposite. We're trying to bring a tiny benefit to everybody. So I'm trying to see BCI as becoming a mainstream thing. And the way I'm thinking of it is what I call implicit user interfaces or passive user interfaces, where the brain signal is being measured, used in real time to affect what's going on. You still have a mouse and a keyboard, your hands still work fine, but we use this as an extra input without you really thinking about it. We're not trying to fool you. Of course, you got the gadget on your head, but we're not trying to distract you with it. So that's our corner. I think it's close to the people up here and not close to most of the rest of the HCI world. I believe this will someday go mainstream. I have no idea when. I'm heartened by seeing a big panel at CHI. But someday, I think the kinds of devices we're using are going to be cheap, widely available. They're already sneaking into, they're already starting to come out. Excuse me. So as a scientist, we're trying to take baby steps in that direction. I cannot read your thoughts. What I can do at the moment is read the amount of workload going on in your prefrontal cortex. It's sort of working memory, executive function, time-sharing kind of stuff. So I can measure how busy you are. Someday, perhaps we can measure more. So the interesting thing, I think, for us in HCI is what should we do with that to make a good user interface? How would that information help us improve situations? So, I should also mention, no, all right. on the same slide, I should mention that we're using near-infrared spectroscopy. Some of you may be familiar with this. You shine a light into your head, and you measure the amount of light reflected back out. You thought your head was opaque, but there's a range of near-infrared light that goes right through. We're not using it because it's better or worse than EEG. It's really sort of complementary. It's less precise in time and more precise in space than EEG. So it's just another type of device. It's also, I can imagine it becoming very cheap eventually. The thing we use is an expensive lab machine, but it could become very cheap. And you see a picture there of someone using this thing. It's just a rubber pad, goes against your head, no grease like EEG, put a headband around it, and that's the end of it. So we can imagine it in, in a hat or something like that. So I'll describe the least hard to explain system that we built. Our challenge is we have this passive parallel signal coming in. What should we do with it? So this was a system for controlling drone airplanes, UAVs. It's like air traffic control. You have several airplanes you're driving, and you have to keep checking with them. So it's sort of a working memory time-sharing task. You check with this one, okay, you check with that one, and then you check back. The question is, are you getting overloaded? Do you have too many airplanes? Should we take one away and give it to a putative team member so your workload goes down? Or are you getting bored and we should give you an extra airplane? Could we kind of keep you in the zone? We could do that if you had a dial where you set, now I'm busy, now I'm not busy, now I'm busy, now I'm not busy, but it'd drive you crazy. So instead, could we do this sort of automatically? And we did just that. We had people, subjects control these airplanes, and when their workload went up, we took away a plane. When their workload went down, we gave them an airplane. And the whole thing lives in a sort of a framework that's like a video game. So we've got measurable results. And we indeed got measurably better performance. So we're really looking for objective measures, not people telling us, I kind of like this because it's cool, but I'd really like to get a measurable performance result. So that was one example. We built a number of others. So some other things we've done are music learning. We decided when to give you the next lesson based on your mental effort. We've built a bunch of these different things. We built one for Google Glass, which is a great application because you could add this forehead sensor right into the device. And this is beginning to be done for other AR and VR displays. Our first one was 2 robots that you're controlling. When you get too busy, one of the robots goes on autopilot. And when you're not too busy, the assumption is autopilot is not as good as you driving. And I can't see if Erin Soloway is in the audience, but if she is, yay, there's Erin. And that was her project. And she had the very good idea early on, this was our first experiment, what if this is all nonsense? Like, what if we're kidding ourselves? So the idea was, so we had it set up so when you're busy, the robot goes on autopilot. How about, she said, let's plug it in backwards. So when you don't want autopilot, the thing turns on, and when you do want it, it turns off, just to make sure something's going on here. And indeed, it gave much worse performance. So it helped us feel like we're not just kidding ourselves. All right. And so we've also done a bunch of work on calibration and training machine learning models because this kind of stuff is terrible with machine learning, but we're getting better at it. So, challenges. There we go. Obviously, the one big challenge is, for all of us, better sensors, better data processing techniques, stuff like that. Machine learning is not a great fit for these kinds of signals because you don't have millions of samples and they're time series. But that applies to everyone. What I think the interesting thing for the CHI community is what kinds of user interfaces should we build? With this kind of continuous, parallel, passive information, what should we do with it? I mean, I think of our problem as two powerful information processors, if you stretch the point, of communicating by a narrow bandwidth channel. Can we improve the communication somehow without distracting the user too much? I want this all to be kind of subtle. There's no general solution. We, as HCI designers, have been designing a bunch of different interfaces and getting measurably better results. A couple other things we tried. We did one experiment on bidirectional BCI, where we added TDCS, transcranial direct current stimulation. And the idea there is when your workload was up and we needed you to work a little extra because something had to be done, we'd give you a jolt. It's just a mild, it's not a jolt. And then when your workload went down, we take it off. So we had this notion of a bidirectional connection. We couldn't get this to work very well because it takes too long. It took us 9 minutes generally for the TDCS to give it effect, and we don't know how long it takes to go away because people didn't sit there that long. So I think there's a future, but we gave it up. And the another obvious issue is the ethical issue. I think the big ethical issue here is who gets the data. If this is a self-contained system built into my phone or my glasses or something, the data doesn't go anywhere, I think I'm okay with this. If the data is going to a server at Meta or the CIA or someplace, this is very scary. But the technical aspects are kind of the same either way. And one more thing I think is another interesting point for this community is the software for this stuff is not easy to write. We've got 2 parallel streams of information, the mouse clicks and all the normal stuff, and we have this passive stream of input. Unlike conventional mouse and keyboard, I don't think they should be multiplexed. They should be treated as 2 streams that modify each other, and I don't have a good way to write these yet. Like every new interface technique, you hack it up using the old tools. The first GUIs 50 million years ago were hacked up using bare raster programming. So eventually, there may come better tools. So that's a challenge for the user interface software community. Okay.
Thank you so much, Rob. Now we're moving to...
No, please.
Sorry about that. Now moving to last but not least, panelist Sho Nakagome from Meta Reality Labs.
Hi, I'm Sho. I'm from Meta Reality Labs, so I'm the maybe only one from the industry research labs. But yeah, this is actually my first time at CHI, and I'm really grateful to be here. And I would like to thank all the moderators and the panelists to be here to discuss this exciting topic. So yeah, I originally started in the actual neuroscience domain, in the brain-computer interface, deep into it, where I was doing my PhD work on trying to decode the gait, the walking pattern, using EEG, non-invasive decoding techniques, mainly to understand the actual brain, how does the brain function when we are actually doing the walking, in certain parts of the time, we can see certain frequency domain, activate, deactivate, and also the other purpose it was to try to create an application where we can hopefully use these decoders to, let's say, control the exoskeleton, where people with disabilities on lower limb could control the exoskeleton to let's say walk again. So then towards the end of my PhD, I was actually thinking what I should do next. And then I actually was thinking of starting my own company too, on the brain-computer interface, because I was mainly seeing one of the most challenging thing in the brain-computer interface is actually low signals to noise ratio, if you have touched any signals data, and also some kind of product scalability, software, these things I think in my mind can be tackled from the industry side. So that was my conclusion. Then when I thought about it, it was actually difficult to start a company because it actually requires a lot of expertise, not only from the researchers side, but from the industry, leading hardware engineers, electrical engineers, software engineers. So we actually need a very collaborative work. So then I actually joined previous Facebook when we were doing a brain-computer interface. We had an amazing team where we had a lot of expertise, not only from the neuro domain, but from the actual industry leading hardware, electrical engineering, and also software engineers. So we actually had a fabulous few years creating a prototype of a brain-computer interface using diffuse optical tomography. And it was actually a state-of-the-art during the time, and then we published a paper. Unfortunately, we concluded the BCI work at the company, and then now I'm working on something called neuromotor interfaces. I don't know if you have seen some wristband where you can measure the EMG on the wrist to try to control a certain interfaces. So yeah, this is just in a very high level what was my trajectory. And then like this is a question asked by the moderator. So what I want to kind of like raise like certain concerns after seeing a lot of like HCI researches is actually like neurotech is not magic just yet. Like, people think of like, if you put the sensors on top of your head, you can actually get, any information. No, that's not true. Like, it actually requires extensive like hardware, the signal processing techniques and machine learning techniques, and then finally you can get something meaningful out of it. So I just want to like, make sure like we do things right. I think like HCI community is actually a professional prototyper. So if you know how to do things right, I think the neurotech is actually a really great tool, like to, being able to like create a new future interface. So my question that I always ask is like, is that really a neuro that you are decoding? Because sometimes I see like a paper where they claim it's a neural signal, but actually it's actually maybe like eye blinks artifacts, or it could be a motion artifacts, or it could be like a EMG, like when you're speaking. So these are actually the noise in the neural signals. So claiming this as a neural signal is actually not good pathway forward, in my opinion. So like if you are trying to claim like we are going to use a neural signals or neural related like signals for the HCI interface, I think we need to do things right. So this is where I think like I want to raise the question of like, try to really think about what's possible with the neurotech as of now, and then like what's actually not possible as of now, and then try to keep up with the the both domain of like HCI and also the neuro, because like both fields are advancing forward day by day. So like this is my like question I wanted to cast to the community. But thanks again for listening.
So, to kick off our discussion, what do the rest of the panelists think about Show's last slide? Patty, Rob, Olaf?
Sorry, what do we think?
About Show's last question, his last slide. Yeah.
I don't know whether I have a particular comment. Obviously, there is a lot of noise in the signal, so hopefully there's a little bit of signal as well. And it's definitely quite challenging to work with all of these technologies because of the high noise ratio. Yeah.
There's a flip side to it, which is if whatever the signal is, I don't care what it was, whether it was eye blinks or what, if it tells me something interesting and actionable, maybe I'm fine. I don't have to care whether it's...
Olaf, you said, Rob said like HCI's like mission is to create a user interface for the neurotechnology, but as a neuroscientist working in cognitive neuroscience, what kind of like interface would be very helpful from your perspective you need from HCI?
Yes, so maybe we should separate the non-invasive from the invasive ones, and I absolutely agree with what was said before. I mean, the invasive ones are very limited, right? They will reach eventually maybe more individuals, but right now they don't. So clearly on the non-invasive side, I think a human-computer interface that, I mean, a dream for me would be like a vest-like scenario that really interacts with this multisensory system, not for the hand necessarily, because there is 90% of the work going on this, but really for the torso, to have a touch-embodied representation really of the unitary sort of person as a whole. I didn't have time to go into this, but in terms of consciousness, in terms of self-consciousness, this would be a beautiful system to have, and then to at the same time, of course, not just sense from this body part and to actuate and to stimulate, but also join this and merge this with non-invasive brain stimulation. So this would be fantastic. Obviously, on the invasive side, more sensors and stimulation devices, initially starting, I mean, not so few patients in Parkinson's disease could be a very interesting condition where the brain-computer interface research takes off much more quickly than in tetraplegic patients. But I think, again, something on the torso, a wearable textile that can actuate, stimulate, and record would be fantastic for memory, spatial navigation, and self-consciousness.
Yeah, so that's fantastic. And then this came to my mind, like when we think about this, like wearable text and stuff, like show. Do you have any like instance of like thinking about the form factor of the device that you have experience in like having a hard time or any challenges in designing this like really usable form factor of this like wearable new technology?
Yeah, so yeah, like building a proper wearable in my mind is very, very difficult. I think as a prototype, you can quickly construct like certain wearable to just prove the concept. But when we think about, you know, scalability, how can we ensure this like a new prototype of a crazy idea can be actually be used with a lot of people? This is where I think, you know, the reason why I kind of chose the industry research, because we could actually try to, you know, make the prototype into more sophisticated form factor. But this is where you actually need a lot more expertise from not only just the researchers, but there are really, really valuable, you know, insights from the hardware engineer that worked in the field for like 30 years, just, you know, making this mechanical engineering, like, you know, insights, also like electrical engineers and such. So I think this is at the point where you know, start from 0 to 1, but like, you know, you actually scale from 1 to 100. This is where you try to collaborate with not only in the academia, but also in the industry side to ensure like we have a, you know, a great like minds working on the scalability of the wearables.
Yeah. So recently we've seen devices like Neurable release a pair of headphones that uses EEG to record brain signals. The Muse has been out for a long time. Emotive has also come out with earbuds that can record brain signals, earables. Do you think that these are technologies that HCI researchers should consider using in their studies, either to create applications, to get quantification of user states, those kinds of areas?
I'm going to have two answers. One is no. If you can afford it, go buy the high-end laboratory equipment. Just see, to give the best case scenario. And then when it's time to disperse this out into the world, we can move to the cheap ones. On the other hand, it is going to make it possible for a lot more people to think about this problem.
Patty, what do you think?
No, I agree. Indeed, if you have the research funding, you might as well make it easier on yourself rather than harder. Yeah. With better technology.
Yeah, like in my mind, like I think you need to think from the different perspective, like where, you know, whether to use like certain devices is not the good way to think about it. You have to like, you know, have a end goal, like what's the interaction or like what's the end goal that you want to actually enable, and then, you know, kind of backtrace back to what's the best, like, you know, the product or the sensors that you should actually use to, like, you know, actually enable the end interface. I think that's the right way. So, you know, it might be, you know, good for you, like, but you have to, like, think not, like, locked into, like, certain modalities, because that's actually one thing that could happen in the BCI community, because, like, we focus so much on the neural signals, but it could actually be enabled from other sensors. Like you said, like people, you know, like in the neural domain, like we think like eye blinks, like, you know, jaw clenching, these things as a noise and just throw it away. But these can be actually a good feature, like if you want to enable like certain interfaces. So yeah, like just think about like what is the thing that you want to actually enable, and then go back from here. Like I think that's the right way to think about this.
Yeah, and I think, I mean, as researchers, we try to look ahead, right? And maybe think about what technology will be maybe more affordable, et cetera, say 5 or 10 years from now. Maybe right now it's still very expensive and cumbersome to use, et cetera, but we sort of develop for whatever the future is going to be like 5 years from now. And yeah, so rather than being limited by the commercial technologies that exist today.
Yeah, and I think the cumbersome technology is a time machine that lets you start prototyping the things that will be available in a few years. And you do want to convince yourself that this stuff will be available. So if I claim fMRI is going to be widely available cheap in a few years, you can laugh at that. I can't imagine how it's going to be possible. But some of these other technologies, yes. So I want to be able to point to a cheap technology coming so that my research will be useful, but I don't need to work on the cheap technology yet.
Yeah, so Olaf is actually like an amazing example about using both of these like readily available wearable, mobile systems for, VR and AR, but at the same time for stimulation, Olaf's team uses like a very high-end like fMRI or like a brain stimulation devices. So what do you think is like a gap between these mobile systems and then on the other hand, like high-end like brain sensing and stimulation systems?
Yeah, no, interesting point. I just wanted to add, maybe, of course, I fully agree that these low-budget sensors are maybe less interesting for us, but I think a great advantage they could bring is in longitudinal signals, so that you have 24/7, and so there may be something interesting there, monitor people really for a long time, so healthy individuals. And I could also think about clinical applications, epilepsy, Angela, for the kind of inner ear system, that, even haptic feedback could be provided. Again, thinking more about maybe therapy, predicting signals and giving some form of haptic feedback that could be learned via these data. So I think it's also interesting, but of course, for the kind of projects that we're all getting excited about, I think the high-end system, no matter how expensive it is, right, that's why we're in academia, and we don't have to worry whether there's going to be somebody eventually who takes this further. Yudai, to your question, we're really at the other end, right? So we are very interested in the lab in particular questions. So anyway, to get to that area in humans, which is difficult, so whether it is by collaboration with clinical partners or having a 7 Tesla fMRI, I forget the price tag now, which is in the tens of millions of Swiss francs, but it's a whole community using this. I think it's the question who really drives what kind of interface is most relevant for us. But again, I think that sorry to repeat myself, but it's really the torso seems to be completely neglected in terms of haptics. And that's even obviously on the side of the neuroscientists too. If you open any textbook, we have elegant, high resolution on our fingertips, and that's what we use on smartphones and so on. Obviously, for braille reading, that's what is used. But if you look what happens with the rest of the square meters of skin that we have, we actually don't even know that, whether it's an animal, whether it's humans, and I think the field of haptics and computer interface is a bit similar, right? Everybody goes to similar kind of areas. So I think there's a lot of potentials to look at what can we do as an interface with a foot. People have gone to the tongue, I think even Baki Rita a long time ago, but I think the torso is really there as a large screen and a large interface. I don't even know what I do personally with my torso all day long, right? It's just there, but it has a very large surface of skin. So I think for me, to integrate this with different kind of systems would be fantastic.
Yeah, and well, related to that, Angela, you've done work on egg or signals that we can get from the gut brain. The second largest set of neurons is in your gut. And there are actually medical monitoring systems have been developed to sort of sense the electrical signals in the gut brain. And it's largely not explored in the whole BCI field so far. Yeah.
Yeah, so I want to get a chance to talk about stimulation since we want to talk about both. So do you want to share maybe where you think people should be thinking about using sensing versus stimulation, if that is something that they want to integrate into their research? Like the relative advantages, disadvantages, or exciting opportunities?
Well, I think relatively little has been done, at least in our field, in stimulation. Most of what I've seen is reading brain activity and then using it in some way for assistive devices or as a secondary input, as Rob mentioned. But there's actually not that much that has been done in terms of stimulation. So I find that to be a very promising area, sort of influencing interoception, for example, or in general, influencing a person's state to put them in a more optimal condition for whatever task it is they want to do, whether they have to be attentive, or they have to be relaxed, or they have to be creative and do divergent thinking versus convergent focused thinking, and so on. These are all opportunities, I think, for stimulation.
Not explored very much, as you say. I would like to do that in very real time. Like we notice something, and now you need a little boost here, and now you need a little boost there. That seems like where the fun is.
Do you have any thoughts, Joe?
Yeah, so, yeah, I agree, like, there's not much to be, like, not much research on the stimulation side. So I think that's, like, the same in the, the neuro domain as well. If you consider the amount of work that's doing the reading, yeah, it's always, like, difficult to do the encoding. So, yeah, like, if there's more research, that would be awesome. But in my mind, it's also, like, the encoding research in the HCI, if we can actually do with the coupled way with the sensing side too, like I think that would be awesome, because usually what I see is like you develop like a certain encoding techniques, you do the experiments, and then like you do the questionnaires to see like how it's working. But the problem is like this questionnaire can be very subjective. So like if we can somehow like sense like what's actually happening to the person, where the encoding is actually doing, I think that should, close the loop and, complete the research. So I would like to, like personally, I would like to see like that kind of research, because then you can naturally, if you were working in the sensing domain, you can tap into the actual encoding too, because now you already have like, sensing techniques and expertise. Now you can do the encoding to close the loop. I think that would be an awesome research direction to see.
Yeah, like closing the loop, but when we think about the non-invasive stimulation, but the stimulation side is still fundamentally limited to the surface level, like a cortical level. So I want to ask you, Olaf, the question about like, is there any way we can stimulate the deeper region of the brain non-invasively, or do we have to actually implant these electrodes to everyone?
Yeah, fantastic question. First of all, I like very much your system that you very briefly showed, that TMS can be applied for many reasons. I think that's already a fantastic start, that, personalized, individualized, we can do this. I think there has been recent advantage for electrical stimulation, so-called temporal interference, that has been used. So combining two stimulation frequencies and then reach deeper surfaces. So I think electrical stimulation is also interesting, and focused ultrasound would probably be my strongest candidate for neuromodulation, and to do this ideally in real time. Also, to go back to the question, I think we need to stop continuously stimulating or stimulating one area, but this closed loop idea that the panel discussed just before, I think will be critical, right? To stimulate, but the right amount in a certain area, but depending on the state of the brain and the person's body, I think these closed loop systems will be fundamental to achieve further advances. And again, Parkinson's disease, with a very invasive approach where exactly this kind of research is happening, but again focused on motor functions. So what we're interested in is also what happens with mental functions in these conditions, and what happens, for example, with cognitive decline and cognitive function in these closed scenario settings. So non-invasive again and invasive, two different settings, but the closed loop character is, I think, fundamental.
Yeah, so since we're coming up on the last 20 minutes, we'd love to take some audience questions. We have some Slido questions, but we would also welcome people to come up to the microphone as well. So one question is, why are there so few neuro papers at CHI this year?
There's never been very many.
Were they rejected or were they never submitted? I don't know.
There've rarely been more than, I'd say, 3 in a year.
Yeah, and there isn't really another good venue for this type of work, so
Yes.
yeah.
Yeah. So I would say we don't fit very well in traditional BCI conferences because they're heavily focused on disabled users. We fit better with physiological computing folks who are measuring, heart rate, blood pressure,
Right.
things like that. There's a small conference every other year called Neuroadaptive Technology, which fits what we're doing, but it's small and infrequent.
Are you gonna take?
Yeah.
Yes.
Okay, yeah, really interesting panel discussion. Thank you so much for sharing your perspectives. One thing that came to mind is, we've had these neurotechnologies. A lot of the technologies that you shared today is something we've had for decades. And we've known about the rubber hand illusion also for decades. And we know that it's sort of limited to you cannot move your limbs, and that will kind of ruin the rubber hand illusion effect, kind of making it hard to maybe transfer into a more mobile setting, a scenario like that. So I think the question that I'm kind of interested in is why now? Why do you think that now is the time to do NeuroCHI and kind of expand into this community? Is there new technologies that you're excited about, or yeah?
Well, for Rob, it's not now. He's been doing this for a while.
We've been doing this for about 10 years. One thing that inspired us was about 10 years ago, Disney 10 published a paper using a modest EEG device and a heavy dose of machine learning. And he claimed he knew nothing about neuroscience, but machine learning makes it possible for any idiot to do this stuff. Well, he said, okay, we'll sign up. So that's what got us going. I mean, I had always wanted to do this, but I thought I had to be a neuroscientist to do it.
It would be great if you could elaborate on that, specifically how maybe your experience as a computer scientist and scientist allowed you to start using this technology without needing to have a neuroscience degree necessarily.
Okay, so I'm a little bit cheating. We have a colleague in biomedical engineering at Tufts who's a pioneer in FNIRS, and he's sort of helping us understand what's going on and how this technology works. And we had a neuroscientist postdoc in our lab also, so
Right.
and yeah, so we've learned a little bit. But there's another point of view, which is we don't care. We want to get some actionable information, which when we act on it, something good happens that we can measure. And we're not trying to understand the brain, we're trying to just use the signals. So that's the sort of
Very
Philistine
interesting.
point of view, which you could take.
Although I would qualify what you said as not being cheating, because historically HCI has always collaborated with other fields. I think we started as a very interdisciplinary field that wasn't necessarily, cognitive science and human factors engineering and everything. So maybe that's one of the ways that we can overcome this challenge of, there are so few neuro papers, maybe there needs, cross-pollination is one of the things that could help, people feel more confident working in this area.
I have another view. So, if you remember the keynote speech, AI is actually the main topic of the past 1 to 2 years, right? And I think in my mind, a BCI can be divided into brain and computer and the interface. So brain is always the sensing part, and then there's the interface. But the interface actually became much more mature. AI can do a lot more things, but but the actual sensing part is still very slowly advancing. But if you think about recent trends, you see a lot of research where they were using a very established traditional a non-invasive BCI signals from multi-imaginary SSVEP, only a handful of classes, but actually translating that as maybe a game computer buttons and then passing that to LLM or AI, they can actually accomplish a lot more tasks that we never even imagined about. So I think, that's one trend that we definitely see, and I think that kind of answers the questions of why. And but at the same time, this is somewhat a little dangerous because we're kind of like, pushing everything to the AI side. So this is where I think like the human comes in, because like human also needs to learn how to, interact with these AI. So this is where HCI can, bridge the gap between the AI and the actual human, right? Like, so coming back to the keynote speech, I think like a really good like a role as a HCI community is to actually enhance like human to, being able to like keep up with these like, magnificent like application that's happening. So, in order to do that, we need to build an interaction with like human and the, the actual application side. So I think that's in my mind why now, like now is more than important, like especially seeing how it's advancing on the application side.
Thank you.
Yeah, like I actually wanted to ask Olaf about like, with this kind of like a recent surge, like, do you potentially consider to submit to Kai in the future?
Yeah, I wish I could have been there this year. I wanted to also go back to the rubber hand illusion, which was a fair comment, right? That the illusion has been around, and typically the illusion breaks down if the person moves. But that's if you do the experiment in the lab. So the question is well taken, but the kind of examples I showed very briefly, and many people today use virtual reality, for example, to create embodiment for virtual hands. And then, of course, with tracking, you can fully integrate movement signals as well, and you can expose people for longer periods of time. So I think the integration of movement signals obviously is important, but can, of course, be achieved exactly by the kind of community that I think Kai is. And again, the hand is a particular dynamic example with a lot of movement signals. And again, I think the torso, with a lot less movement, with a lot easier predictions, I think is a very good target to do to not only do torso representations and tracking and stimulation in the lab, but and not only in VR but also in real time. So I think the NeuroCHI is a natural extension, I think, of non-brain directed human-computer interfaces. So for me, there's is really no difference. So it's a natural extension.
I really love to hear these comments from you, Olaf. Thank you.
Hi, thank you so much for all these ideas. So I worry a little bit about the magnitude of the benefits or the effects that we see. So I would like maybe the panel to talk a little bit about like, where are the areas where we are most likely to see, like, I don't know, improvements that are not like in the single digits per se, or something like that. But I don't know, radical differences in how people are able to accomplish some tasks. And also related to that, I would like to know your opinion on what kind of benefit or level of benefit we would need to see in order to see widespread adoption of this kind of technology, because it also has a certain discomfort or cost that you're paying for this.
Paddy, what do you think?
So suppose the costs go down, the discomfort goes down. I don't need very much benefit to win. What's the benefit of the mouse? It's cheap, I can just use it. I don't need to justify it. So what's one answer? Second answer is we've gotten decent, well over single-digit improvements in performance. And the third answer is for the stuff we're doing, we're measuring a signal which you didn't really think about this. Your workload just went up. I would drive you crazy if I took a strong action based on it. So in those scenarios, we're not going to get huge benefits. But if we get any benefit and the stuff gets cheap and fits in a baseball hat, why not?
And it doesn't take effort from the user, so yeah.
Thanks a lot.
The mouse was once a very expensive device that very few computers came with. So you had to justify it. And eventually, like, it's free with every computer, don't worry about it. So that's why I'm thinking we may head.
Hi, thank you for the discussion so far. So as you know, with the stuff that's already being tracked online, like usage on mobile phones, eye tracking data, hand tracking data, and things like that, there's already a lot of privacy concerns, some of it because of misinformation, some of it because there's actual concern and whatnot. now we're talking about measuring brain activity and stomach neuroscience, neurosignals and whatnot. What are your thoughts about the ethical concerns or ethical ideas, ideologies around that stuff?
Yeah, I think it's urgent that we have these discussions now, and that we come up maybe with sort of standards for our community even, or expectations for our community for sort of, yeah, what types of principles guide our work. There's a good book, and I'm blanking on the name of the person from Dartmouth, on the ethics of BCIs that came out a year ago or something. What's her name again?
Freedom to think or freedom of thought or something like that was the theme, if I'm thinking of the same book.
What's her name again? The woman from Dartmouth.
Is it The Battle for Your Brain? Is that?
Yes, yes. Thank you. Thank you, Erin. Yeah. So it is, these discussions are starting to happen. I read that the state of Colorado is actually debating collection of brain signals and whether it should be allowed or not, and yeah.
No, they've already added neural data to their Data Privacy Act.
Yeah.
As of very recently, only a few weeks ago, yeah.
Does this change if it's entirely self-contained, if the system doesn't connect to a server? I don't know.
I would think so, yeah.
Would like to believe.
Yeah.
Is there any your experience based on your industry research about the ethical implications of this neurotechnology show?
Yeah, good question for Meta.
Yeah, so first of all, I can't talk about the company's specific directions, but we also always take, especially the research labs, we always take this ethical issues and bias like privacies, really, really crucial. And I think it's, like all the other panelists said, it's always important to discuss and implement this as early as possible in the research domain and as often as possible when things are getting updated. And yeah, I think industry and academia are no different in this aspect. You should always think about the research in the perspective of the privacy and all the ethical implications in place. And also you should always get consent of conducting experiments and such. So I think this is no different where industry or academia, it has to be done right. So yeah, that's what I think. Yeah.
Olaf, you are also running this research with medical domain and sometimes longer term with the participants, right? Is there any ethical procedure or knowledge that you think can be also applied beyond the medical studies or more wider domain?
Yes, yeah, thanks. I think, yeah, it's an important point that was raised, and I think a lot of efforts are ongoing. I think, I've participated at a meeting at the UN exactly about neurotechnologies and the impact. People always clearly separate the non-invasive consumer-type technologies and the invasive ones. I think everything in the clinic is pretty standard at the moment, although, of course, we also don't know in which direction eventually this will go. So there are certain countries like Chile already who has already a limited neurotechnology and privacy rights. And there is, of course, the question that was raised, there is the idea, there's the issue of neural privacy in addition to the other data. Although I think at the moment, what a consumer would give away with the neural data, unless you know exactly the paradigm, is a lot less identifying than other kinds of data, right, that we all share already worldwide with many companies in terms of mobile phone use and other systems. So I think, but there are other issues why neuroethical questions are critical and different eventually. There's things like cognitive liberty or mental and cognitive integrity, because we will become at some point dependent on these technologies, and we see this again most clearly in clinical examples, right? If you have a DBS or a pacemaker for the heart and you would just stop the system, well, that are very severe consequences, and the brain is even more special in this. because these devices could change self-identity and memory systems and so on. So, but I mean, there are efforts, I think, worldwide at the level of the UN, in New York, but also in Geneva there have been meetings, and also at the EU, for example. But questions are always, does it go beyond what has been done in the biological field, or why should neuro be special, and should that be special human rights compared to the existing human rights? And this is an ongoing discussion. So yeah, it's an important issue. But I still think we have a far way to go on the neuro side to really be of direct relevance for these questions. But better to discuss them ahead of time than post hoc.
That's actually like a wonderful HCI research question. Right?
Thank you.
Hi, Purvesh from Virginia Tech. Thank you for the discussion. The discussion mostly revolved around using brain and the neurology of the brain. There were little discussions or points on mind and the thought, which is primarily used in HCI. HCI researchers primarily depend on thought, surveys, and questionnaires. So my question in that regard is, what do you think is the role of the mind and the thought in NeuroCHI and PhysioCHI technologies? Thank you.
The mind is in the brain?
Yeah.
I'm not sure I believe in that duality.
Yeah.
I know it's a controversial topic.
Yeah.
So I guess the point, yeah, I guess the point that I was trying to make is that yes, the brain and the brain signals can give us some, can be used to control interfaces and can be used to predict some of the psychological states or thoughts that the human can experience. But how do you think, and again, the discussion was mainly focused on how to use these signals to directly control some interfaces or modify or adapt an interface or controller technology. Do you think there is a role of thought also, like the kind of experience someone is going through or the kind of emotion someone is feeling in adapting that interface?
Eventually, yes, if we could sense things better, is one answer.
So yes, if I
why,
may
I
add,
guess, let me rephrase that. Why not in 100 years? Is there any fundamental reason why not? I would say no. Is it going to happen next Kai?
Okay. Thank you.
All of us saying something here.
Yeah, so this relates to the. So obviously, I think these high-level mental states are as represented as a finger movement, right? So I think one way to approach this question of using brain-computer interfaces for the mind is to look at more motor planning stages, for example. So intentions to move and eventually not moving, and this is what we studied in this last patient example I gave. So one could decode not just movement, but also intentions to move without ever doing the movement, and those were slightly different areas. And once you're talking about intention, free will, and voluntary movements, also the sense of agency, you're very much in important subjective states, whether and they are mental in the truest sense of the term. So and so brain-computer interfaces, of course, can directly relate to those as well. In these research settings, it all depends on the particular experiment you're carrying out. But I agree, most of the work is on movement and haptic feedback, and our brain mostly is doing cognitive things. If you just think about the size of language areas, right, that's massive. And speech decoding obviously is another area where mental constructs are really being decoded and also used for stimulation in order not just to move and allow tetraplegic patients to communicate or to enable actions, but really to communicate verbally.
Thanks so much.
Thank you, Olaf. We'll take one final question from Erin. Great person for this question. Yeah.
Okay. Yeah, so I guess I have a lot of questions, but I'm Erin Silve from Worcester Polytechnic Institute. But I guess a question related to the stuff about why now, and also why are there only 3 papers or something. Where do you see HCI researchers making the contribution? Because this is very interdisciplinary, so what should be published at CHI on this topic versus somewhere else? Because there is papers being published in other journals and other things, but what should we all be doing? There's a lot of people here. What kind of contributions do we make to the field, or does HCI make into BCI, traditional BCI, or do we bring over to HCI?
Good question. Thank you very much. What I don't think would be exciting at CHI is better technologies for measuring the brain. That's like, a mouse that works better. But how do we use this in a user interface, especially when it's this subtle, passive, implicit? It's not, I'm thinking a special thought to make the window shade go up. But these subtle kinds of interfaces, how should you use them? What's the user interface design question? That's our job, I think.
Yeah, and I think we use computers for more tasks. It's not all about work and augmenting how we do our work or improving the tools for work. We're using computers to manage our mental health. We're using computers to learn. So all of these other areas, we're using them to assist people with all sorts of non-work tasks. So especially in those areas, I think we can do a lot with these types of signals that we can get from the brain and with stimulating the nervous system and brain directly. Yeah.
One thing I would like to kind of recommend is actually try to, if you can, of course, try to go to the certain, a big, a neuroscience conference too, because, for example, Society for Neuroscience, that's the biggest conference. If you go there, I think you can find, good opportunities where HCIs can actually help the BCI side. On the other hand, we should also encourage BCI people to come to the CHI, because I saw a lot of really, really great research where we can directly use this idea in the BCI domain. So I think right now we are lacking somewhat, a good collaboration between the two communities, completely separated. Coming from the neuro background, I honestly didn't know about CHI, although this is the biggest conference in the HCI. So if we can find a way to, kind of go to each other's biggest conferences, I think that's could, collaborate, do a lot of good collaborations, and also think about a new potential ideas for research.
Raf, do you have any collaboration that you can imagine with HCI researchers?
Yeah, I mean, nothing to add really. The last comment was to the point, right? I think the communities need to interact more closely. So I was fortunate to work at a School of Engineering, EPFL in Switzerland. So there were mechanical engineers and haptics and robotics and VR all around me. So it was natural to look for that collaboration. Again, for the main reason that I'm a neuroscientist interested in body representation. So I think this collaboration for me has been very important, and I think there's nothing really to add. Those communities, if they work together, if they find touch points on either side, I think it will actually lead to many breakthroughs.
Yeah, thank you so much, Olaf. And also to shout out, Aaron wrote a great textbook, Brain Input in HCI, co-authored with Felix Putz. That's a really good introductory and detailed read if you want to get into this area, learn more about the different ways it can be used in HCI. It's great. Before we conclude, it would be great to hear some concluding remarks on what you're most optimistic for in this area, or just any last comment you want to share about challenges, opportunities, etc.
Go ahead. I think it was just mentioned, but I think that there's just reading neuroscience literature, and I've always had a couple of neuroscientists in my research group also for the last 6 years or so, and it is indeed, there's a wealth of sort of ideas there for interesting things that HCI could experiment with and could incorporate. So I would like to encourage more people to start looking towards that other field for inspiration.
New tools make it possible, excuse me, to build cooler and more tightly coupled interfaces, and this is going to make it amazing. Cool interfaces, I think, is where we're heading.
Yeah, and yeah, coming back to like certain questions that was asked, like I think like HCI people are, really professionals in like, rapid prototyping, and like this is my first time in CHI, and I really enjoy like all the presentations and the research that's happening here. So yeah, like we said, like I think we should like definitely collaborate as much as possible. Whether it's a reading paper, attending conferences, but like with the rapid like improvements in like the application side, I think the HCI side is actually the one who can bring the human into this like equation. So if you can actually build like the interfaces that interact with these, and then try to understand like what's the human, like what's the AI, like how can we advance like the both domains. I think that's like a really potentially like really promising area that I would like to see.
Yeah. Olaf.
Yeah, human-computer interaction, I think it's a massive field. We're scratching the surface. Actually, it may completely replace how psychology and cognitive science is done at the moment. If we could recreate fully controlled digital robotic haptic environments to fully test human beings, I think this would be a dream scenario. And also, for the neuroscience point of view, there's just in terms of just perception, tactile perception, so much to do. We don't even know where thermal, heat, hot and cold perception is, more complex patterns. We have a lot of knowledge in the visual system. We don't have that for other somatosensory systems. And then the integration of neuroprosthetics and brain-computer interfaces will never work without the HCI community eventually. This is really a convergence that must happen. Otherwise, brain-computer interfaces will also fall short. So these would be my three conclusions.
Really lovely remark. And with that, we would like to conclude the first NeuroCHI panel. And yeah, and this is just the first step, and we will keep working on, and to near future, we will really make it, right, Angela?
Yeah, I hope that I can really, and also if you look in the panel proposal paper that's in the proceedings, there's more details there about like background, different papers, ideas that we hope can be inspiring. And I really like what Olaf said about how HCI is needed in these other fields, and you can create new discoveries about how people work, because cognitive scientists, neuroscientists, et cetera, they're all using digital technologies, VR, in their research, and it can be significantly improved by the kind of work that HCI researchers do. And then on the other hand, there can be this interplay, like HCI researchers can also benefit from the insights that neuro and cognitive scientists have and the tools that they use. So thank you everyone so much for being here, and we all hope that you learned something, or if you're already in this area, that you really enjoyed being part of the discussion.
Thank you so much.
Thank you.
Olaf, let's take a photo. Right?
All right.
How is the photo going to?
How do we get Olaf in the picture?
How do you want to do this?
Our colleague just works as a camera and tripods.
Does anyone else feel like we're in the movie Brazil? I mean, I think they did this on purpose. It is like kind of surreal a little bit. This gigantic room and the lights and the
Yes.
So did we take the photo?
I don't know. I think Jazz took some, but
How did you plan on doing this? Never mind. We'll figure it out. Maybe we could